All right, so we talked about, was it last lesson? No, I think maybe the lesson before. We talked about central angles. Do you remember that? All right, so let's take a look at, oops, hit shift. Let's try this again. Hit shift key. There we go. And we'll make that kind of big. All right, so here's a circle. And let's put, oops, where was it? Missed it. There it is, right there. All right, there's a center. That's pretty important when you draw a circle. And so this first part is just a little review. All right. So let's say that's, I don't know, 110 degrees. And there's A, and there's B, and there's, call it X. All right, so what do we call that angle right there, that 110 degree? It's got a name for where it's located on the circle. What do we call that? It's a central angle, right? This is a central angle. And what did we learn about the central angle? Central angle cuts off an equal what? An equal arc. So if this angle right here is 110 degrees, so angle AXB is 110, then what is arc AB equal to? 110. Couldn't be much easier than that, would you agree? So this arc right here is 110 degrees. Well, that's old stuff, right? That's a central angle. Let's write that down. That's review. So that's a central angle. But look at the title of today's lesson. It's not central angles. What is it? Inscribed angles. So what in the world is an inscribed angle? Well, I'm glad you asked. Oh, I got rid of my center. Let's put another center on here. There we go. All right. So if you're talking about an inscribed angle, let's do this in a different color. Let's go blue this time. It would not have the vertex at the center. So a central angle, the vertex is at the center. Okay, on an inscribed angle, the vertex is actually on the circle itself. Everybody hear me? It's not called an onscribed angle, but inscribed angle means the vertex is right on the circle itself. So there we go. I could say that is an inscribed angle. We'll call this A, call this B, call this C. That's good enough for what we're using right here. So this angle right here, angle C, is called an inscribed angle. Now, there is a relationship. Just like there was a relationship between the central angle and the arc that it cuts off, there's a relationship between the inscribed angle and the arc that it cuts off. So let me try my best here. Just to, that's good enough. All right, so that arc right there, that big fat blue arc, okay, that would be an arc that is cut off by an inscribed angle. So this angle right here is an inscribed angle. The arc is just an arc that's cut off from the inscribed angle. We don't really have a special name for it or anything like that. We don't call it an inscribed arc or anything like that. We just say it's an arc that's cut off by an inscribed angle. What's true about the vertex of an inscribed angle? It lies where? On the circle. Okay, so this is an inscribed angle. Everybody good with that? Yeah, it's pretty easy. Now, there's also a relationship between the angle and the arc that it cuts off. It's not going to be equal. When is it equal? When the angle is a what? Central angle, okay? Is this a central angle? No, it's not, all right? So we have a theorem that says that the inscribed angle, this angle right here, so angle C, the inscribed angle is equal to half of the arc that it cuts off. It's half of arc what? In this situation, arc AB. All right, everybody see that? So it's a theorem, all right? It's a theorem that says that if you have an inscribed angle, it cuts off an arc and that angle is half of the arc. So let's say this was, I don't know, what do you think it is? 50? Looks pretty close to 50. Let's use that. Okay, if that's 50 degrees, then what is arc AB? It would be 100 degrees. Okay, because remember, the angle is half of the arc. The arc is bigger than the angle. It's twice as big, isn't it? I could have written it this way. I could have said that the arc is what? Double or 2 times that central or that inscribed angle. It's pretty easy, isn't it? Yeah, it's not quite as easy as the central, but it's good enough. What if, just for the fun of it, let's put the central angle and make it cut off arc AB. All right. Just by knowing that this angle is 50 degrees, we should be able to tell what that angle right there is going to be. What's that going to be? It's going to be 100, right? Because if this is 50, the arc is 100. If the arc is 100, then the central angle is what? 100. Make sense? All right, yeah, pretty easy. What if I have this? What if I had another inscribed angle and it goes to A and it goes to B? We'll call it D. Yeah, so what's that angle going to be? It's also going to be 50, isn't it? Because it cuts off the same exact arc, right? So if this inscribed angle was half of arc AB, well then angle D cuts off the same exact arc, the same 100 degrees, right? So it's got to be what? 50 degrees. Does that make sense? So I could do all kinds of inscribed angles. If they keep cutting off at A and B, then every one of those angles is going to be 50. Make sense? Yeah, that's not too bad. Yes, go ahead. The arc go the other way? Like ADB? No, because it doesn't, you don't have an angle that goes from here. Well, okay, let's do it this way. I think. Let me see if this works. Yeah, what if I go from here to here? Okay? And I asked you what this angle is. We're still using the same exact information that I've given you. So what arc is it cutting off? A, yeah, you could go AD or C, it doesn't matter. ADB, right? Remember, this is a major arc because it's more than 180 degrees, okay? So you could call it ADB or you could call it what? ACB, doesn't matter. Any point in between. So what is that? I don't know if I can draw this. It's going to be ugly, but I'll go real fast. Maybe it'll work. That's not too bad. All right, look at that big, thick green arc right there. All right. So how many degrees would that big, thick green one be? It'd be 260. That's right. Okay, so arc, what do we call it? Let's go ACB. Is that right? ACB. How'd you know it was 260? Because the blue one right here is 100, and that's what's ever left over from the whole circle, right? Whole circle's 360, so 360 minus 100 is 260. So what's this angle right here going to be then? Is it 260? 130, that's right. So this, because it's still half, but it's half of this arc though, this time. It's a good question. Everybody okay with that? All right. Yeah, I'm going to skip that little bit right there. All right, let's go right to an example. Go ahead. Yeah, if they, like, let's say you didn't know that was 100, right? But they told you that, and that's the only thing they told you. Then what would this arc be? The arc is double the angle. That's right. Remember, the arc on the outside is bigger than the angle on the inscribed angles, okay? So it's not just bigger, it's what? It's how much bigger? It's 2 times as big, right? So it's twice whatever that is. Make sense? So we could go either way. They could tell you the arc. You should be able to find the angle, right? So if they tell you the arc, it's half of the arc is the angle. Or if they tell you the angle, then how do you find the arc? You just double it. You're good to go. We good? All right, let's do an example. There's a circle. And you got lots of stuff going on here. So let's say that goes to there. This goes to here. And we got one going to here. And we got one going to here. Look at all that mess. And they don't even give you a center. It doesn't even matter. And they tell you that this is 55 degrees. And they tell you that this is 60 degrees. And they put some letters in here. So let's fill in with some letters. V, W, X, Y, Z. All right. And they ask you for two things. They ask you to find angle VYX, angle VYX. And then they also ask you to find arc WX. All right. So this is what we're trying to find. So let's find the angle first. Let's find like where it's located, and then try to figure out how we're going to actually find the measure. Okay, this is find the measure of these things right here. So VYX, where is V? Right there. Where's Y? Right there. And then X. Is that right? I don't think I meant X. I meant W. Sorry about that. I was looking at my example. I'm like, wait a minute. I don't even have a line that goes from Y to X. I mean, you could find it. Nah, I don't think you could find it. It's because I miswrote that. It's W. VYW. There we go. So that should be a lot better. There's V, there's Y, there's W. So what are we trying to find? I'm trying to find that angle right there. So how do you find it? Well, you look to see where it cuts off, right? Hopefully there's an arc that it cuts off, and it does. It hits at W right here, and that angle hits at V right there. So really, what are we just trying to find? We're trying to find half of what? The 60. And Noah already said it a long time ago. So if that's 60, how do you find the angle? Just divide it by 2, right? So it's just 60 divided by 2, which is, of course, 30 degrees. This little angle right there is 30 degrees. Pretty easy, right? And the next one's kind of easy. Kind of. Takes you a little bit of extra. Arc WX. So where is arc WX? That's this arc right here. So that's what we're trying to find now. Well, we got a little problem. Let me make sure I'm doing this right. WX. Yeah. Can I find it directly? No, I'm going to have to do something else. So where am I going to go? Well, let's look at this 55 right there. Okay. Where does it go? It goes from here to here. Everybody see that? So what is this whole arc, the green one and the pink one together? Let's do it a different color since... Yeah, if this is 55, then what is that arc from V all the way to X? It's 110 degrees. But that's not what we're trying to find, is it? Because the 110 goes from there to there. Agreed? But we're just trying to find the pink one. Pretty easy. What do we do now? That's it. 110 minus 60, and that's 50 degrees. So this pink one, let's make it pink, is what? 50 degrees. You okay with that? So we still use the same principles, but it wasn't exactly as easy as the first one. The first one was pretty straightforward. This one, you knew the whole arc because of that being 55. You already knew this little part right here, that green part. So what's left over? 110 minus 60, which is 50. Everybody good with that? Yeah. Now, we did something earlier. It really wasn't part of the lesson, but I knew it was going to happen, so I wanted to do this. Watch. See this angle C? It cut off arc AB, and arc AB was 100, wasn't it? All right, and look at D. It cut off the same exact arc. So we have a theorem that says if you have congruent circles or in one circle, all right? Actually, do they say the one circle? Let me see. They just say, or the same circle. Does it say that on there? I did not write that in my notes. I should have written that, shouldn't I? In congruent circles or in the same circle. Okay, so we already saw the same circle. So let's make this a little smaller so I can put two of them on here. So there's one. Copy, paste. There's another one. So here's what the theorem says. Again, this is one that you could probably look at and you're like, well, yeah, of course, that makes sense. All right, it just kind of looks like it would make sense. Let me copy that and paste it. I copied and pasted it because I wanted to make sure. Oops. Oh, come on. I'll get this in a second. There we go. Watch. I'm just going to twist it around. So did I change the value of that angle? Did I change the angle measurement of that at all? No, I just twisted it around. All right. So if this was 30 degrees right here, and I also said this was 30 degrees, tell me something about these two arcs, A, B, and C, D. Both arcs would be what? Well, no, they're not necessarily 60. Arc AB. You know what? I don't know why I did arc AB. That was dumb. My bad. By you saying 60 made me think about what I was doing here. There we go. That should be A. All right. Now, what would arc AB be equal to? 60. And what would arc CD be equal to? 60. What if I said this, though? What if I didn't tell you they were both 30? What if I just said that they were equal to each other? What if I just said that angle X and angle Y are equal to each other? Then what could you say about arc AB and arc CD? They got to be equal to each other. That's right. Because look, both of those angles are the same. So this is twice this angle. This is twice the same exact angle. So what's left over has got to be the same. Would you agree? So if I double a number, then I double that number again, I'm going to end up with the same exact value. So what's true here? That arc AB is congruent to arc what? CD. Without even knowing the numbers. But you throw the numbers in, then it really makes sense, doesn't it? If they're both 30 degrees, then AB, arc AB is 60 degrees, and this right here, arc CD, is also 60 degrees. So there you go. The two arcs are equal. But you didn't even have to know the numbers, did you? You just had to know that they cut off, or these arcs right here were from the same measure angle, all right? So those two angles were equal. That means the two arcs are going to be equal. So that was pretty nice and easy. Let's do another one. This is kind of cool. I like this one. Oops. Now I got to go back and copy this circle again. So here we go. All right. This is kind of cool. We're going to take what we learned about the inscribed angle being half of the arc, but what we're going to do is we're going to put a diameter in here. Let me put a point where my center is, right there, and I'm going to try to hit that. There you go. So there's a diameter. Would you agree? So check this out. Without any numbers at all, I'm not giving you any numbers, you should be able to figure out. Let's click off of that. Did I click off of it? There we go. Watch this. I can go anywhere on the circle. Where do you want to go on the circle? Right here? Good. And if I connect one end of the diameter to the other end of the diameter without knowing any numbers whatsoever, all I did was connect, okay, anywhere on the circle. Pick any point on the circle. And if I connected to one end of the diameter to the other end of the diameter, what is this angle right there? Say it. Why is it a right angle? You're correct. Why is it a right angle? Because what arc does it cut off? Look, this comes here to here. So what's the arc that it cuts off? It's this, right? Everybody see that? How many degrees is that thick arc right there? Speak up. I can't. Okay, because you're whispering, I can barely hear you. All right, so that's 180 degrees because from one end of the diameter to the other end of the diameter is half the circle. Would you agree? Yep. So that's got to be 180 degrees. So guess what? This angle is half of this arc. So if this is 180, what's this have to be right here? That's got to be what? 90 degrees. Half of 180 right there. That's kind of interesting, isn't it? All right. So without knowing any numbers at all, okay, you should know that that's a right angle. So if you ever wanted to draw a right angle and make sure it was a perfect right angle, what could you do? You could draw a circle, draw a diameter, do an inscribed circle to both ends of that diameter, and you got a perfect right angle. It's kind of interesting, don't you think? You're not as excited as I am about this, it doesn't seem. Look at this. Watch. I'm going to go somewhere else on this circle. Let's go right here. And let's connect to the diameter, to the ends of the diameter. Check it out. What's that angle going to be? This angle? That's going to be 90 as well. I could keep doing it all along this circle, couldn't I? Well, I did this half of the circle. Let's do the bottom half of the circle. Let's see what that looks like. So again, anywhere, where you want to pick. Let's go like really close. Nah, it's not too close because this is so thick it's hard to tell. So what if I went from there to there and then from there to there? What kind of angle is that? That's also 90, right? Because I hit the two ends of the diameter. So this is going to be 90 as well. You don't seem as excited as I am about this. Why not? All right. I understand. How old are you guys? 14? Something like that? 14, 15? Are some of you 15 yet? Anybody 13? Everybody's 14 in here? Okay. So anyway, for a 14-year-old kid, I can understand it may not be the most exciting thing in the world. But I would say it's interesting. Wouldn't say it's exciting, but I would say it's interesting. So, all right, let's do this. I don't need the center in there, so I'll just leave it like that. Watch this. What I'm going to do is I'm going to inscribe. You've heard that word before, right? Inscribed angles. So I'm going to inscribe a quadrilateral inside the circle. What does that mean? Just going to make a four-sided figure, and every vertex is going to hit right on the circle. I'm just going to do any four-sided figure. I'm not trying to make this like any particular type. Let's just go down to here. Let's go to here. Would you agree that that's an inscribed quadrilateral? How do I know it's inscribed? Because look at the vertices. Every vertex lies where? Right on the circle. Everybody see that? So if you have a situation like this, we have a theorem that says, that the opposite angles of an inscribed quadrilateral are, what do you think? Like this angle right here and this angle right here. They're not equal to each other. They are supplementary. Because look, that looks obtuse, that looks acute, okay? And they will be supplementary to each other. So let's call this A, B, C, and D. So what can I say? That angle B plus angle D must equal what? 180 degrees. Everybody see that? Let's see why. Because look, angle B comes out and it hits right here and it hits right here. Agreed? Angle D does what? Hits right here and hits right here. Okay? Everybody see that? So, what arcs do they form? They form this big arc right there, angle D does, and angle B forms this big arc right here. What's true about those two arcs? What do they add up to be? 360. But what's an inscribed angle do? It's half of the arc that it cuts off. So what's half of 360? 180. Do you see it? You see why it's true? I think that's kind of cool. And then we're going to put all kinds of arcs on this one. 3 here and 4 here. Did I put 4? There we go. And then what else is true? Angle A plus what? Angle C is also 180 degrees. And why is that? Angle A hits here and here. So what's it do? It cuts off that big arc. Angle C hits here and it hits here and it creates the rest of the circle, right? So the two angles cut off 360 degrees altogether, right? And so what are the angles going to be? They're going to be half of the arcs that they cut off. So what's half of 360? 180. And that's why they are supplementary. So if you have an inscribed quadrilateral, let's write that word down. Did you write it down? Inscribed, quadrilateral. So if you have an inscribed quadrilateral, the opposite angles are supplementary. That's what it's saying right here, okay? That the opposite angles are supplementary. Okay. All right, that's pretty good. One more example and we'll be done. Ready for a good example? So make you think. So let's get ready. Let's wake up. Get ready to think a little bit because this is the kind of stuff you're going to see on a quiz or on a test. Did that wake you up or not? Quiz, test? No? Should. It should. You guys will be whining and complaining when we take the test. You're like, oh, I didn't know how to do that stuff. Well, this is the time. Right? So you got lots of stuff going on here. We got one more to draw right there. Oh, you know what? Oh, this should have been... Yeah, that's not bad. It does. It goes through the center. I meant to make it do that, and it does. Got lucky. All right, there's the center right there. So what is that line that goes through that center? That's the what of the circle. It's the diameter. So that's pretty important as well. What do they tell you? They tell you that arc DAB. Oh, I got to put some letters in here, I guess. A, B, C, and D. The center we'll call P. And I think that's everything they give you. They tell you that arc DAB. Does anybody have the book open? That little arc, or the angle, BCA. Do they give you BCA? Do they give you this angle, though? 68, okay. I have it in my notes. I couldn't tell if that's what they gave you or if that's what we were trying to figure out. But, yeah, that makes sense. All right, and then DAB is 208. All right, so I think that's everything that they give you, and you got to find a bunch of stuff. So find 3 things. Part A, find an angle ABC. Part B, angle BDC, angle BDC. And then part C, angle DAB. DAB. You guys still do that? Is that a thing? Do people still do that? Isn't that kind of old now? Yeah. I never did that. Anything that was a trend, I never did. Okay? So I was just not cool enough to participate in any of that stuff. But that's okay. I'm an old guy. I shouldn't be doing that stuff anyway. So, all right. So let's put in the DAB, arc DAB. Ooh. That's going to be, I'm just going to put it right here. 208 degrees. What? We had no trends. Boomerangs? In Australia? They do. My parents have several boomerangs they got from Australia. All right, here we go. Angle ABC. This is actually an easy one. Yeah, look at it. There's A, there's B, there's C. We didn't have to know any of those numbers in there at all to do that first one, did we? Because what's it do? So here's your angle. That's what you're trying to find, that angle right there. Where does it go? It cuts off at A. It cuts off at C, which is a what? Diameter. How do you know it's a diameter? Because it goes through the center, okay? And so if it cuts off a diameter, it cuts off 180 degrees, so what must it be? 90 degrees. So that would be 90 degrees. So that was easy. Okay, it's the other ones that are a little bit tough. BDC. It's angle BDC. BDC. So let's do this in a different color. We don't get them all mixed up. BDC. What's that skinny little angle right there? Well, it cuts off arc BC, doesn't it? But do I know arc BC? I don't. What are some other things that I could find though? Let's do this. Let's not be so concerned right now about finding that angle. Let's just take the other information and just try to figure out what else we could possibly know. Natalie, what do you see? I don't know. Just did a whole lesson on it. You tell me. This is an inscribed angle, right? It cuts off what? It cuts off what? Not an equal arc. It's not equal. If you know the angle, what's the arc? I know, but I just took like 20 minutes talking about this. So look, I'm sorry. You had a good question. I mean, it was good that you had a question. But look, it's not equal to that arc. What's the only things that are equal? The angle and arc that are equal. If it's a what? If it's a central angle. Do I even have a central angle here? No, I don't even have any central angles. But I do have this. All right, so this is an inscribed angle. So if I know the angle, how do I find the arc? Is the arc half the angle or double the angle? It's double. The arc is always double the angle. Okay? So if this is 68, then what is that yellow one? Double it. 68 plus 68. That's 16. That's 12. That's 1. That's 136. So that yellow one is 136. How does that help us find this angle? Doesn't really help us just yet, does it? Is there anything else I can find? Okay, we could do that. Let's do that. Okay, see this AD right here? Well, actually, no, that will not work. Oh, gotcha. Yeah. Perfect. Okay, see? Keep asking questions and keep saying stuff and you'll get it right. So look at this. This is a diameter, correct? So I know this is 136. How could I find the rest of it? This BC right here. We'll make it the same color, okay? So what is that BC right there? It's what? 180 what? Minus 136. Is that 44? So this is 44. Okay, so that 136 was important, wasn't it? I would have never found this to be 44 if I didn't know that was 136. All right, and that angle was important. They had to tell you that to find that that was 136. Got it? Now, why does that one help us? Because look at D. Cuts off arc BC, doesn't it? So if that's 44, what's this little yellow one right here? It's 22. And that's our answer, isn't it? That's what they want you to find. Angle BDC is 22 degrees. Very good. All right. Let's keep rolling. Angle DAB, where's that? DAB. That's this one right here. So what do? We look to see what it cuts off, right? So this goes all the way to here, and this goes all the way to here. So if we knew that whole arc right there, if I knew that whole blue arc, then I could find this angle right there, couldn't I? Well, Maybe we can. Say it again. Yeah, there we go. Okay, that's good. So we could go, because you know the whole circle is 360, right? So if I start here and I go all the way around to there, that's 208. Then I go to here, that's 44. So what's 208 and 44? 252. Is that right? Okay. So that goes, is that what we wanted? 208 plus. Okay, then I can find this little bit right there, and then I can. Or it'd be a lot easier if I just did what? Yeah, exactly. That's what I was thinking. Right. I mean, you could go that way. It's just like an extra step. But you could just go what? 360 minus 208. Would you agree? And what is that? Is it on my paper anywhere? What is it? 152? Okay, good. All right, so that blue one, that blue arc, that's 152. I'll write it right there. So how do I find this angle? It cuts off that blue arc, doesn't it? So if the blue arc is 152, how do I find this angle? Just take half of it. That's right. So 152 divided by 2 is 76, I believe. And that angle is 76 degrees, and this angle is 76 degrees. And there we go. Found everything that they wanted you to find. Some of them took several steps, didn't they? All right, so that's what you got to get used to, okay? It's not always going to be, oh yeah, it hits the diameter, it's 90 degrees. It's not always going to be like that, okay? Yeah, so this is what we're trying to find, that blue one, which is 152. The way we were going, you could have done it that way. What were we going to do? What was the way we were going to do it? The 360 minus 208 to get that. Then you take away 44, you're going to be left with 152. Yeah, that would have been fine. Or you could just gone 360 minus 208. That's the easiest way to do it. Then take half of it, and then there you go. All right, what do you think? We good with inscribed angles? It's not really that hard, is it? All right, the only thing is you just know that the arc is twice as big as the angle. If you know that, that's basically this lesson. Okay? All right, let's do some homework. Wouldn't want to send you home empty-handed, would I? So we're going to break this up into A and B, I believe. Did I do that on here? Well, no, I didn't really. Oh, I'm looking at the wrong page. I was looking at last week's. Yes, I did. All right. So part A is, let's see, what is it? 8-4A. I'll give you both of them. It's 1 to 13, and then 8-4B is 17 to 29. I'll collect it on Wednesday, 8-4B. But if you want to get them both done, if you want to go tonight and get them both done, make them two separate homeworks though. All right, so when you get to 13, don't stay on the same page and start at 17. Change to a different piece of paper. All right, so do both of these separately. But if you want to get them done tonight, then great. Then tomorrow you don't have to do anything, okay? You are going to stay for a quiz because we have a quiz on Wednesday though. All right, so there you go. Yes. Nah, we're just gonna review for the. I'll go over. Try to do as much as you can. I'm gonna collect them both on Wednesday. Okay, so we're gonna do A and B on Wednesday. I'll collect them both. But tomorrow, I'm gonna go over the answers to both of them. Is that all right? All right, so I'll go over the answers to both of them tomorrow. I'll collect it on Wednesday so you can hang on to it to study for the quiz. The quiz on Wednesday is 8-3 and 8-4. So the quiz on Wednesday is 8-3 and 8-4. 8-4 is what we did today. All right, so that will be on Wednesday. Everybody good? Okay.